Okay, so there are several safety features in a household circuit. We're going to talk about, what, 1, 2, 3 of those. The first is the circuit breaker, which, as we said, breaks the circuit. The second is grounding of your household circuit. And then the third is the GFCI. Some of you might know what a lot of these do, but we're going to talk about it. You'll need to know, what they do, how they operate. First, let's see the circuit breaker. The circuit breaker are a fuse. Some of you have circuit breakers, some of you have fuses. Or if you live in a house like ours, our house was built in the 50s, we have a circuit breaker box and a fuse box. In our house, the circuit breaker tends to operate the lower voltage devices, and the fuse box operates the higher voltage devices, like the electric oven. Although we have a gas oven, we have an outlet for an electric oven, or the electric dryer, or the electric heater. So those are very high voltage devices. They operate at 240 volts, and those things in our house are on a fuse box. The circuit breaker, I have a picture here of a circuit breaker. A fuse, on the other hand, looks like this. It looks like a little light bulb, but without the light bulb. And if you look up at the top of it, there's a little window, and then you'll see a little tab, something like this. And when the fuse is blown, that tab is all burnt up, and you get like soot inside the window. So a circuit breaker or a fuse turns off a circuit if the current exceeds the safe capacity of the circuit. Most household circuit breakers will turn off if the current exceeds 15 or 20 amps. And so here's your circuit breaker panel. Often these things are usually black. Usually if you look on the handle of your circuit breaker switch, and this is just a single circuit breaker, you'll see a 15 or a 20 there. And that represents what is the maximum allowed current on that circuit. Remember, we can figure out the current on a complete circuit using our power equation, P equals VI. So for example, if I have a 1200 watt heater and it's operating at 120 volts, then I know that my current has to equal 10 amps. All right. And if I have 2 of those, then the total current on that circuit would be 20 amps. And if I have 3 of those, the total current would be 30 amps. Circuit breaker looks like this. It has a bimetallic strip that bends when the current exceeds a certain value. If you recall from last semester, if I have a bimetallic strip and I heat it up, it's going to bend in one direction or the other. And we use that, for example, in our thermostats to measure temperature, so that when the room heats up, the temperature will bend at one direction or the other. We have a similar application here. When current flows through the bimetallic strip, it heats it up. And as it heats it up, it bends one direction or another. And so you see our current comes in here, it travels through this bimetallic strip, and if it bends too far, it'll bend back this direction, it'll cause this to close down and open the circuit. Now, other circuit breakers work with an electromagnetic switch. It's a little bit different, which we'll talk about in the next chapter. It uses a magnet, which you see here, an electromagnet. And basically, let's see, where is it? Oh, here it is. This is connected to a magnet that sits inside an electric field or a magnetic field. And when that magnetic field, which is produced by the current, when it exceeds a certain amount, it will disengage that switch. This is like a solenoid switch, which we'll discuss in the next chapter. So these are just 2 examples of how circuit breakers work. I think these are the only examples, actually, of how circuit breakers work. Yeah, here's a better example of the electromagnetic switch. You have your current coming in like this, and if your current here exceeds a certain amount, it will pull this back and cause it to turn off. Don't worry too much about how that works. As I said, we will discuss solenoid switches in the next chapter. All right, here's a quick test. You can try this. This is similar. I think we've had a similar question to this before. You just want to figure out what is the maximum allowed current for this breaker. I have a couple things, 3 things that are operating. Each of them pulls a certain amount of current. But then when I add this fourth thing, it turns the circuit breaker off. So somewhere in between the current required by those three things and the current required by those four things is our maximum allowed current for the circuit breaker. So give that a go. We will pick back up with grounding in just a few minutes.